Hey guys, what's up? Joe here. I'm gonna check out a couple different puzzles today just to show them. The first one called Nurikabe. So I don't like to go too high because the numbers get too small and it's kind of hard to see. So we'll do like a 15 by 15 hard. So that's about my limit there as far as how tiny I want it. Even zoomed in. Let me just see. Make sure I still feel that way. Ah, 20 by 20 doesn't even go to hard. Yeah, so we'll do 15 by 15 hard. But anyway, on Nurikabe, the numbers represent little islands, and basically islands cannot touch each other unless it is just diagonally, like this 2 and 4, for example. Um, so, and then all the water has to be orthogonally connected, which means it has to share an edge. It cannot only touch diagonally like the islands, but it has to actually go in like a left, right, up, down manner, and it cannot be a 2 by 2 section. Like this would not be good. Cannot do that. So, first off, I mean the easiest, most obvious thing are the little ones. Those are their own little island, so you can just surround them with water. You can't do the diagonals because the island could go there. But whenever they're, so we can just do all those right off the bat. And you just kind of do like the cardinal directions for them. Also, the islands that are touching at a corner, you can just immediately put water on both of the other sides. Same as like if they're one square apart. Neither one of those could touch because then the islands would be touching, and that's no good. So it would be like something like this around the grid. I think that is probably most of them, if not all. So once you have that sorted, you can kind of start just working out, like working your islands outward. So you can see like the 2 only has one option here, so it's done. And whenever it's done, you just surround it the same way with water. You can also kind of just count 2, 3, 4, 5, 6, 7. So the 7 could go in there, but it doesn't. But it'll make sense in a sec. I missed one there. This 2 is forced out. Whoops. This 2 is forced out. It finishes it. This 2, when they're like this, I only know that this 2 goes either up or to the right, but whatever direction it goes, it will get water here, because it will be complete, and nothing else could touch it. Like this 2 couldn't come over because then this 2 would have nowhere to go. So this 2 is forced outward, downward. This 2, either way it goes, that would be blocked. This cell here cannot be reached by anything now. The 2 couldn't make it up there. It also made this almost a 2 by 2, so the 2 is being forced up to block that. And the 5 here, it could go over, but even if it does, that's only 2 so far. So we know it gets at least 3, 4, 5. Now this little 1 cell water is almost blocked in, so it has to come out. This 2 is being forced upward. This is made a 3 by 3. It must be gotten to by something. The only thing that can get there is the 9. So the 9 can start working down toward it. We can also take note of how many cells that's going to be already. 1, 2, 3, 4, 5, 6, 7, 8. So it's already 8. 3, 4, 5, 6, 7, 8. It's already um, it's already 8 tiles big. And so we know it could, if it came this way, it could only come over one. So we know this one cannot be reached by anything now. We know this one cannot be reached. We made a 2x2. We know this 2 is being forced out. We know this one can be reached. We made a 2x2. That one must be blocked. Here's a 2x2. We know that has to belong to the 9. We still remember that 9 can come out one more in whatever direction. The 8, we'll start moving it out. The 4, we start moving out. The 7, we know has to go up this way somewhat, or else there's going to be, because the 2 cannot reach here, the 2's cannot reach this square here, so it has to come up to at least there. And it can actually only go down one square at maximum, so it has to go up at least 3 more of these squares somewhere. But that can be later. This 2's being forced out. This 3, nothing can reach this square here. This has already got 4, so it couldn't, because that would be 6. The 3 is 4 away from it. This has made a 2x2 almost, so that must be going straight toward it. This one is, or this 1 cell water is almost trapped. It has to go up downward to its friends. This one needs to come up. This one can go either up or to the right. If it goes up, something will need to come here. 1, 2, 3, 4, 5. And the 5 cannot reach it. So, that is water. This is now 2x2. That completes the 5. This is almost a 2x2. So, it will be part of the 5. Also, we can start working some of these out to give us more insight about the others. If this 5 came over to the left, it could only come one spot. So we could just say, for now, we can count it as 2 and know that it has to come over at least 3 this way. Well, just starting it coming out has told me that this has to be water. And then it comes out again. Now it is a maximum of 4. It doesn't necessarily tell me anything positive now. If anything was to go here, right here in this cell, it would be the 6, but doing so would single out this little bitty section of water, so nothing goes there. What else do we have here? And it's good to kind of look for, water that has to get out to its other water buddies. So, another thing that could be said is that, like, if this 2 were to come down, then there would be water up in this corner, and it would have to get out. But in doing so, it would need these 3 spots here. And then, let's just do it real quick. Would the 7 have enough room? It could only come down 1, so that would be 4, 5, 6, and it would have to go here for 7, and then this water would be trapped because the 2 would come over and the 7 would go to here, and the water would only have these 2 cells to occupy, if you can see that. So I basically know that this cannot be water because it wouldn't have a way out. So I can force that 2 island there. Like I said, I know this comes up at least 3. And so now it's gonna, no matter what, it has to go to there because it has to go up at least 3. So again, this water would be trapped if it was, you know, here only, and the 7 had to go farther. So the water comes out this way. This one could be 1, 2, 3, 4, 5, 6, 7, but it could also be 1, 2, 3, 4, 5, 6, 7, like that maybe. It just depends on like what the logic happens down here, if where this black needs to get out, where it's either here or here, etc. So for now we can kind of scan around and look for other clues. Eventually there will be like a section of water that is just getting trapped. Alright, this was maximum of 1 for the 5. So it has at least 1 more way over here, but it could have 2. But it cannot go to there. If it goes to there, then obviously there's going to be a single water cell in the corner. So nothing can go there. The 2 could go up, but it doesn't necessarily have to. With the 3, no matter which way it goes, this is going to be water, which forces this 2, which no matter which way this goes, is going to do that. This could still go up, but we will figure that out more in a second. This, okay, so 1, 2, 3, 4, 5, 6. The 6 could reach here, but the 2 cannot. But what we can say from that is that the 6 most definitely goes up in one of these 2 spots. And it also goes in one of these 2 spots. Because if it didn't, then you'd see there would be a 2 by 2 there. So 1, 2, 3, 4, 5, 4. So this is a 4 already. And then it has 2 to spare. It can go wherever. 1, 2, 3, 4, 5. This 5 is done though, because we know it goes to this corner. So it's 1, 2, 3, and then one of these, and then 5. So that is water because nothing else could go there because the 5 has no more to give. This water either touches here or here. This water is going to need out, and if it went up to get out, you can see that 6 would only have a maximum of 5, so it does get out there. This is going to be mostly full with the 6. It could go all the way, no, it could not go all the way up to here. If it did, the 2 would be forced to go up. If it went, like if the 6 went up to here, this would be water, the 2 would be forced up, and this would be blocked in. Is that what I had there? So we know the 6 does not go there, and the 2 couldn't reach it. This could still touch here to get out. I mean, it didn't mean that the 2 couldn't go up. It only meant that the 6 couldn't go there. You can see that nothing can reach this. So right here, this one already has 3, 4, 5, couldn't quite reach. This 3 can't quite reach, which made us almost a 2 by 2. The 3 got forced into finishing. The 5 has to come out this way at least one more time. This water is now almost blocked in, so it does have to come down, forces the 2 up. This water could go either way. This water, if this, if this came up, no, rather, if the 8 came over, it would make water right here. And then it would have to go out this way. 3, 4, 5, 6, and the 8 wouldn't have enough squares. So the 8 cannot go there, and the 5 cannot go there because 8's already right here. So that is water. And now maximum 1, 2, 3, 4, 5, 6, 7. So this is getting real close to being maxed out. And in fact, if this water has to go out right here, because if it didn't, like, it can't go up and over whatever. If the 8 came over to here, then it would be trapped, and if the 8 went up, it would touch there anyway, but it would also make a 2 by 2, so the water has to go out that way. And now I think this is maxed. This is 1, 2, 3, 4, 5, 6, 7, 8. It is. And it's maxed because it couldn't go in there and touch the 5. It can't go to either one of these because it would touch the 2. So this is now like that, and the 5 is done, and this water has to get out, and this is done. And again, this water here, it can't get out this way, so because this would only have 4 spots for the 6, so it must leave there. It forces this 6. This water here is almost trapped, so it must go down. This water could go out right there, which it may very well do. This water could go here. Oh, the 2 is forced down. The 7, I think, is going to be 2, 3, 4, 5, 6, 7. Yeah, the 7 is forced. So that water had to get out. That has to happen there. This water needs out. This water is going to need out as well. Finishes that. It needs to finish getting out. Yeah, this water here is either going to get out. Oh, actually, it's going to get out right there. That small section here had to get out. But now, this section up in this top left corner, it's also going to be trapped, but it's going to be trapped by this 9 going down this way, right? So this couldn't be part of the 9 because we know that the 9 is coming down to this corner. So since it gets this and it gets this, then it's going to meet up here and make an impassable wall, so to speak. So it has to go out there. Now it could still like come over one or whatever if needed, but the 9 couldn't have went into there. This is going to have some water that's going down through this way somewhere, because the 5 and the 9 are gonna make, like, a wall with their water, because it cannot touch. Now, that being said, this water could still come over to here and down to here or whatever. I think it's going to eventually have to come down to here and connect, but we'll see. Might just finish this up, maybe, if I can. Might not be able to yet. I might have to do this middle part. Looks like it. The 4, though, is going to have to come over to somewhere over here, or else there's going to be a 2x2 right there, and it can't come down to here. This is made a 2x2, so it has to go straight across. So we can do that. That made a 2x2 almost, and that happened. Okay, so 9 does have to belong to at least one of these. Just 3 has to belong to at least one of these. The 5, though, we can't forget the 5. That's kind of a big number to be parked next to a 9 in such a little bitty cramped area. Is there something that is blocked? Okay, this whole section here now is blocked. And it's got to get out right here. This is oh no, it could get out right there. Okay, so it's got a slight give there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it depends on this 5. I think, what if this 5, what if this was water, and this 5 had to come out like such? It couldn't go over to there, and then it would be messed up here, because it couldn't come down. So this is not water. That is part of the 5, which makes that water. This comes down. This could or could not be part of the 5, but even if it is, we know this has to be as well. So that's a maximum of 4. This is water because those 2 are about to touch. Now this is a maximum of 5. This has to come out for the 9. This is forced into being water. So the 9 continues downward. 1, 2, 3, 4, 5, 6. The 5 could just stop here like that. And the water would go down. And then it would tuck. The 9 would be forced into this corner if it did that. Oh, well, the 5 cannot go down anymore, actually, because it was one spot away from that 9 island. So that goes like that. This water is almost trapped. It goes down. This water up here in the top right is almost trapped. It goes down. This one must do that, and therefore, all this big section was almost trapped, and it must go down there to touch the rest of it. And that is a Nurikabe. They are fun stuff. Let's show one more. It will be oh, whoops. It will be, where's the list here? Do I go back? No. Nurikabe? No. I forgot how to do that. Oh, here they are. More logic puzzles. Easy. It is going to be a Slitherlink. Once I find it. right here. We'll go about a 15 by 15 maybe. That looks good. I don't remember what this was all about, but let's do a normal loop on this one, just because I might finish that other one later. Who knows? Alright, so on this puzzle, the numbers are the amount of walls that are around it. And our goal is to make one non-stop continuous loop. So it'll go somewhere like crazy all around the puzzle, and like if a thing has a 1 on it, it'll only be touched on one side by the loop. If it has a 3, it needs 3, etc., etc. So immediately we can see that there are zeros in here. Obviously they cannot have a line. On a 3 box, there's a couple things to note here. When 3s are sitting next to each other, you can immediately go like this, with the marks in between and on the outside, like this. Same thing over here as well. When a 3's in the corner like that, you can also just immediately go like that. So I mean, this is almost basically started. So it has to go like that. Now our 1 here is satisfied. Our 2 is satisfied. This has to come on out. This 3 is kind of being forced by the 0, so that has to be, this one has to turn, cannot go downward. It can't be there, so it has to be there. It has to turn there. Whenever a 2 is like at a corner like this, then it's just opposite side. Boom, boom. And then this 3 has started, so to speak, so it must finish. This one comes on around. One of these, since this one is going to be forced, we know that one of these is going to be the wall, so we know that these 2 are not. Since this one cannot go that way, it will go that way, and it gives us that. This one won't be, because it will just dead end, so it goes like that. The 1 is already done, so this is being forced up and around and over. That one is being forced over. Whenever there's like a border like this, then it's just opposite side for the 2, because they would just, you can't branch your loop. The 3s work the same way. If they're vertically like this, you can just immediately go as far over in between each one and on the outside of all the 3s, however many are in a row. So it's same here. The 1 is, it finished the 1 by doing that, which forces this 3 and forces that 3. This spot is going to be forced into one of these 2, so we know that these 2 are not. We know nothing goes by the zeros. This 3 is now forced, which forces that one and that one, and it forces the 2 up, forces this one, makes that one go up, and this one has nowhere left to go but down, so it must do all of this. This must turn down. Whenever a 3 is diagonal with another 3, then you can immediately do the outer 2 like that, and the reason is because you cannot have a corner on a 3, because then the only 2 available would be those. So in order to avoid that, then you have to have one of these sides open. So whichever one of these sides are open, those 2 are always going to be complete. You can only really do that if the 3s are on a corner like that. Now it doesn't really tell us much about the rest of it though, so we move on. These 3s are on a corner though, so we could say the same for it. which it does force that 3, which in turn forces this one, and in turn forces this one. And it also is going to give us the 1, because none of these top or bottom would have worked, because that would have poked into the line. This 1 is done, so is this one. And now that we know which side of the 3 is not marked, we know the other 3 have to be same. Oh, I goofed. I goofed. Let me take it back a notch. What'd I do wrong? I'm pretty sure I was sound until about there. I'm gonna do that again for that, because that is still good. Alright. This one had to come on around. Had to come on around. That one had to do that. That one had to do that. Oh no. Wait a minute, that's alright. What am I talking about? It's okay. What's wrong? What's wrong? What'd I do? That's good. That's good. Everything is golden. Everything is golden. Okay. Phew. Alright, we know this is like that. This only has one way. This has to come out. This has to be that. The 1 is now done. We know the 3 does this number and comes on around. We know those can't be either one. We know this. When this is being forced up, finishes the 1. This, okay, this is coming into the 3. So we know that it has to loop. Anytime it starts into the 3, it can't just leave. So these 2 corners are going to be part of it. So like if it went up, it would have to go that way. If it went over, it'd have to go that way. Either way it goes, those 2 are going to be there. This can't go over into it. It must go up. This is done. That could go up. This could come over. Either one of those 2 things would happen, and it would be like that. This is 0. Now this is marked. The 2 is finished. The 1 is finished, which forces the 3. This corner here would have done the 2, or what I did, and just had to follow around, didn't have a choice. The 1 must go over, the 2 must go like that. This is blocked, so it had to turn right. This is no. This is no, so this has to be. This is no, no. So again, this goes like that because there's a line coming into a corner of the 3. This has to go here. That has to turn. We can't connect our little loop here because it has to be a continuous, non-broken loop. The 1 here is done, which forces our 3, which makes it turn up, turn down. That 2 is resolved. Oh, this 3 has been done for a while, I think. This line here has nowhere to go other than over. That has to finish the 3 out. This has to turn up. This can't go up, it can't go right, so it must go that way. Finishes the 2. This 2, this 1 is there. This 3 has to go up. This is, whatever way this one goes, it's gonna finish the 2, so it can't go there. So this one is being forced that way. This one is being forced down, and it's made a almost closed in box, so we can't close that there. So this is being forced to the right now, this is being forced there. This is on a corner, so it goes like that. It's also finished. This forces up and over and up. This 2 has to go there and turn and make another little box. It can't go up and close. It can't go up, or it would close. So it goes over. It could come touch that 1. Would be fine. The 2 has to go there. Oh, this was on a corner, so boom, immediate. This 2 is like that, so it must be done. This can't go up, so it goes that way. Finishes that. This is being forced left. This 2 needs to go there, which makes that turn. So the 1 is going to have to be marked there. It's going to have to go there. It's going to have to... This can't close because we made a smaller, almost finished loop. We need to put it into the big one. This is being forced this away. This cannot go up. Whenever we're getting close to being like trapped here, well, oh no, I can't see that there. I can't say that for that. But what I can say is, I guess I can do that. Whenever you're about to get trapped, you can ask the question, how many points do I have? Like, how many ends do I have? You have to have an even number, or else it's impossible to time together, right? So if I turn this line up, for instance, you'll see I have 3 left. There's no way to tie them together. So I cannot turn that up. And now I have 4, which is the even number. It's good. Everything is satisfactory. But it doesn't tell me the direction of it yet. But if I do turn this one up, then it's looking very closely to being about to be tied together. But that doesn't necessarily tell me that it doesn't go that way. So we wait that for later, in my opinion. That one goes up. This one could go, it can't go this way, because the 1 would be forced to have 2. But it could go this way and come around and do something like that. Something crazy. Oh, this can't go over into there. That was probably there for a long time now. So this one must go over. Finishes a 1. This one turns. Finishes that 1. Makes that one turn. Finishes that 1. Gives us a 3. Makes it turn. Finishes the 2. Finishes the 1 as well. The 3 must be like that, and turn and turn. This one is still unresolved. This one is one of those. Can't get much from that yet. So this one must turn. This one has to go here. This one has to go that way because it was at a dead end. Otherwise, this one does. It is going to do one of those little funny dealios, but this one must go up. So this one must go up farther. It can't go to the right because it would be dead-ended. It can't connect to itself, so it must go up. This one must go up because 1 has been fulfilled. So it does something like that. Now we're asking 1, 2, 3, 4. We know these 2 cannot connect to each other because it would make these 2 connect to each other, and they would make a small rebellious little loop. So it goes like that. This one is forced to the right. this is being forced this way to finish the 3. This corner on the 2 and the fact that neither one of those can beat are going to make it like that. We got another corner on a 2, so we can immediately go like that. This one is being forced this way, finish the 2, those have to connect, this has to turn, this has to turn this way, this has to turn this way, this has to connect to get the 1 done. And now this is the only spot for that one. It must come down, could not connect to itself. This one is being forced up and turning. This, I thought I saw something there. Maybe not. If the... Okay, one... Alright, this one is either going to be here or here, so we know these two are not. Because those are its only 2 options, and either way it goes, it's gonna not let one get another wall. So it finished this 3, which in turn didn't necessarily do a thing, but it did. This one is being forced downward. This one is now being forced upward. This one is now being forced upward. This finishes the 1, gives us the 3. It gives us the 2 because they can't go down on both sides, and it can't just close right here. Because if it went down on both sides, this one would have to attach and make it 3. So it goes like this. This one has to cut off to avoid the 3, and it has to connect like that. Now we're eventually going to have to impose the question of, if I go this way, am I going to close a loop too early? I'm sure that will come up. Oh, this one is going to end up finishing this 1 here. It had no option. So this one is being forced down. And this one is being forced this way now. This one is being forced here. These 2 cannot connect, or they would make a small one. Can't have it. So those had to connect. Those had to connect. These now have to connect. Those have to connect. And this will finish it up. And that one is Slitherlink, another fun one I like. Hope you guys enjoyed. Have a great day. Bye bye.